Advantages of dimensions. Advantages. There are three advantages. Number one, to check the homogeneity of equations. Number two, derive formulas. And number three, determine units. The question or the topic is advantages of dimensions. There are three advantages. Number one, to check the homogeneity of equations. Number two, derive formulas, the second advantage. The third one is determine units. The homogeneity of equations, the homogeneity of an equation. The first one. The second one, derive formulas, derive formula. It's too easy. We start from here, then slowly we will reach here. After that, we move there. Now, let's check the equation. Vf is equal to Vi plus At is dimensionally correct. It's correct or not, this equation. This equation is correct or not. It's an important short question also. Note down the question. Prove that the equation Vf is equal to Vi plus At is correct or not dimensionally. I'm repeating the short question. It's an important short question. Note down. Prove that the equation Vf is equal to Vi plus At is dimensionally correct or not. The answer of this question or solution: if dimensions of left side and right side are equal, then the equation is correct dimensionally. If not, then the equation is wrong. So let's start left hand side. The dimension of left hand side, on left hand side we have velocity, and the velocity of dimension and the dimensions of velocity are Lt minus 1. On left side we have velocity, and the dimensions on right side we have velocity, acceleration and time. So first left hand side, on left side we have velocity, and the dimension of velocity is Lt power minus 1. Look here, we already did in previous lecture. Velocity is rate of change of displacement, or rate of change of distance is called speed. Dimension of distance or length both are same in nature. So dimension of distance or length is capital L, and the dimension of time is capital T. In denominator T, in numerator T power minus 1. So the dimension of velocity or Lt power minus 1. So the dimension of velocity are Lt power minus 1 on left side. Then was now right hand side. On right hand side we have velocity, and the velocity of dimension is same Lt power minus 1. So first Lt power minus 1, then plus as it is, then acceleration. The dimensions of acceleration, look here, acceleration is the rate of change of velocity. Acceleration is equal to V over T, rate of change of velocity is called acceleration. Now this T stays the same or remains the same, and this V is replaced with d by t. This V is replaced with d by t. Now t multiplied by t square, d as it is, this d as it is, and t multiplied by t square. Now the dimensions of acceleration, dimension of distance or length is capital L, and the dimension of time is capital T, in denominator square, in numerator t power minus 2. So dimensions of acceleration are Lt power minus 2. So dimensions plus as it is and dimensions of acceleration are Lt power minus 2, and the dimension of this time is capital T. Hope you got this. Now this LT power minus 1, LT power minus 1 same as it is, this plus as it is, this L also as it is. Now same basis TT, they both have same basis, so their powers will be added. Minus 2 plus 1, keep in mind, if there is no power, if there is no power written, then it's mean the power is 1. Whenever, keep in mind, whenever no power is written, it means the power is 1. The power is 1. No power is written, it's mean the power is 1. Same, this L has a power of 1 because no power is written. Whenever no power is written, then it means the power is 1. Same, this A has a power of 1, this B has a power of 1. Whenever no power is written, it means the power is 1. So minus 2 plus 1, minus 2 plus 1 with a single base, same basis, then the power will be added with a single base. Now again LT power minus 1, LT power minus 1 as it is, this plus as it is, L as it is, minus 2 plus 1 is equal to minus 1. You can verify on your calculator. Minus 2 plus 1, check on your calculator, it is equal to minus 1. Now LT power minus 1, again LT minus 1 is equal to 2 LT power minus 1, same as x plus x is equal to 2x. Here LT plus LT is equal to 2LT, x plus x is equal to 2x, LT plus LT, 2LT. Now right hand side is equal to 2 LT power minus 1 on left hand side, LT power minus 1. If we ignore the constant, then LT power minus 1, LT minus 1, right hand side and left hand side are equal if we ignore the constants. It's mean this equation is correct dimensionally, because left hand side, the dimensions of left hand side and the dimensions of right hand side are equal. In dimensions we ignore the constants because they are dimensionless, so ignore this 2, it's a constant. Dimensions of right hand side LT power minus 1 and dimension of left hand side LT power 1, both are equal. It means this equation is dimensionally correct. So the question was proved that the equation is correct. Here we proved with the dimensions, because both sides have the same dimension, it means this equation is correct dimensionally. As 2 is dimensionally dimensionless, therefore dimensions of left hand side are equal to the dimensions of right hand side. Dimensions of left hand side are equal to the dimensions of right hand side. So the equation Vf is equal to Vi plus At is dimensionally correct. Now come here, the homogeneity of an equation. If both sides of an equation have the same dimensions, if both sides, left side and right side, both sides of an equation have the same dimensions, left side has and right side same dimensions, it is dimensionally correct. Then it is dimensionally correct. This is the principle of homogeneity. Another short question: what is the principle of homogeneity? The answer is from, and the answer of this question is from here to here. What is the question is, what is the principle of homogeneity? The answer is from here to here. If both sides of the coin has same dimension, then it is dimensionally correct. It's the principle of homogeneity. Here we done the first advantage. Now move on to the second one. The second advantage. First advantage is done, homogeneity. Second, drive formula. Second is drive formula. To drive a possible formula. To drive a possible formula, first guess the factors on which the quantity depends. Let me explain this. Drive the formula for the wavelength of matter waves. Note down another short question. The question is, note down, drive the formula for the wavelength of a matter wave. It's a question. Now, what is matter? What is matter? Anything that has mass and occupies space is called matter. I am a matter because I have a mass and occupies space. This ball is also a matter because it has mass and occupies space. So everything around us is matter almost, because they have mass and occupies space. So the question is, derive the formula for the wavelength of matter waves. So it's a matter. In 1924, a French scientist, de Broglie, said, every moving particle, whether small like an electron or large like a ball, has a wavelength associated with it. I'm repeating. In 1924, a French scientist, de Broglie, said, every moving particle, whether small like an electron or large like a ball, has a wavelength associated with it. Means this ball has a wavelength associated with it when it is moving. So according to this French scientist, this ball has a wavelength when it is moving. So the question is, find the wavelength of this wave associated with this ball. The question is, find the wavelength of the matter wave. The wavelength associated with this ball is known as matter wave because it's a matter. What is matter wave? The wave associated with this matter, with this ball is a matter, with this matter is known as matter wave. Now we have to find the wavelength of this matter wave. We have to guess the factors on which this wavelength depends. Guess the factors. The wavelength lambda depends on the mass of the ball. Mass of the ball, number one. The second factor, speed of the ball or velocity of the ball. The wavelength depends on the mass of the ball, speed of the ball, and the Planck's constant h. There are three factors on which the wavelength of this matter depends. Number one, mass of the matter. Number two, speed of the matter. Number three, the Planck's constant h. Remember this. So, wavelength lambda. So, to derive the formula is the question. So, to derive the formula, first we will write lambda is proportional to mvh. Lambda is proportional to mvh or hmv. hmv. Lambda is proportional to hmv. Yeah, mvh. You can write. Then let me remove this. First you have to write the lambda is proportional to mvh or hmv. Then write ABC. Then write ABC to derive formula. Now, whenever proportionality is converted into an equality, a constant k is added. It's a normal. Whenever the proportionality is converted into an equality, a constant k a constant k is added. Now, dimensions of lambda is L. Why? Why the dimension of lambda is L? As we know that it's a wave. And what is the wavelength lambda? Wavelength is the distance between two crest or turf. Wavelength is the distance from this point to this point. It can be 2 meter. It's a length, and the dimensions of length is capital L. Wavelength is the length between two crests or two troughs. So it's a length, so its dimension is capital L. K is a constant with no dimensions. It's a dimensionless. No dimension of H. What is the dimension of H? The dimensions of H is ml square t power minus 1. Look here. We know that E is equal to HF. E is equal to HF. Rearranging for H. F is multiplying here. It will be divided on the other side. Here it's multiplying. On the other side it will be divided. And we get H is equal to E over F. H is equal to E over F. Now what's the dimension of energy and frequency? The dimensions of frequency. As we know that frequency and time periods are reciprocal of each other. They both are reciprocal of each other. F is equal to 1 over t. And the dimensions of time is capital T, in denominator t, in numerator t power minus 1. So the dimensions of frequency is t power minus 1. Dimensions of frequency is t power minus 1. It's the dimension of energy. Now look here. As we know that work, for example, the work is 8 joule, kinetic energy is 20 joule, potential energy is 13 joule, heat energy is 180 joule, joule. Same unit, work, energy, kinetic energy, potential energy, any form of energy, they all are measured in joule. Kinetic energy joule, potential energy joule, energy, heat energy joule. It's mean every form of energy is measured in joule. They all have same unit and same dimension, ml square t power minus 2. About 2 or 3 lectures back, we studied how to find the dimension of work or energy. If someone missed that lecture, go through it first for the better understanding of this one. I'm repeating, back 2 or 3 lectures back, about 2 or 3 almost. I will put the link in the description. We studied, we learned how to find these dimensions, ml square t power minus 2. It's the dimension of work, it's the dimension of energy, it's any form of energy. So it's a dimension of energy. So the dimensions of energy is ml square t power minus 2, dimensions of energy is ml square t power minus 2, and frequency, and the dimension of frequency is t power minus 1. Dimension of frequency is t power minus 1. Now in denominator t power minus 1, in numerator t power plus 1, and ml square t power minus 2, ml square t power minus 2 as it is. They are as it is, as they are. T power minus 1 in denominator, in numerator t power plus 1. So m as it is, l square as it is, same basis, t, both have same basis. Then the power will be added, minus 2 plus 1 with a single base. So minus 2 plus 1 is equal to minus 1, m as it is, l square as it is. So it's the dimension of H, or the H has the dimensions m l square t power minus 1. So the dimensions of H is m l square t power minus 1. Dimensions of H is m l square t power minus 1 raised to the power a, because h has the power a. Dimensions raised to the power a. Now the dimension of m is capital M raised to the power b, and the dimensions of velocity is L t power minus 1. Dimensions of velocity is L t power minus 1. L t power minus 1 raised to the power c. Now this power a applies on all m, l and t. M power a, L power 2a, L power 2a, 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 t power minus a, because a multiplied by 1 a, minus plus minus. Now m power b, here L power c and t power minus c, c multiplied by minus 1 minus c. Now m same basis, same basis, powers will be added a plus b. If the bases are same, then the power will be added with a single base. Powers are added a plus b with a single base. Now L same basis, powers will be added 2a plus c, Same t same basis, powers will be added minus a minus c, with a single base. Now comparing the powers of both sides. No m on the left side, so its power is 0. On the right side, m has a power of a plus b. On right side, the m has a power of a plus b, but on left side no m is missing, so its power is 0. On left side, no, for L, on left side L has a power of 1. If no power is written, it means the power is 1. L has a power of 1. On right side, L has a power of 2a plus c. Now for t, no t on the left side, or t is missing on the left side, so its power is 0. On the right side, t has a power of minus a minus c. Equation 1, 2, 3. Now we have to solve these three equations for a, b and c. Now from equation 3, here c is negative. If we move to the other side, it will be positive. Here negative, other side positive. A remains the same. So put c is equal to minus a in equation 2. In equation 2, 1 as it is, 2a as it is, only c is replaced with minus a. C is equal to minus a, so this c is replaced with minus a. Now 2a minus a is equal to a, 1 as it is, so a is equal to 1. Now put this value here, a is equal to 1, c as it is minus as it is, a is replaced with 1 because a is equal to 1, so c is equal to minus 1. Now from equation 1, 0 as it is, a is replaced with 1, this a is replaced with 1, b plus as it is, b as it is, plus 1 here, on the other side minus 1, so b is equal to minus 1, so a is equal to 1, c is equal to minus 1, b is equal to minus 1. Then this equation becomes lambda is equal to k, h power a is equal to 1, so h power 1, m power b b is equal to minus 1, so m power minus 1. Now m power c is v is equal to c. V as it is, this c is replaced with minus 1. C is replaced with minus 1. So minus 1 in denominator plus 1, minus 1 in denominator plus 1. So it's a formula for the wavelength. Formula for the wavelength, lambda is equal to k h over mv. Lambda is equal to k h over mv. Our question was derive the formula for the wavelength of matter wave. Derive the formula, we derive the formula for the wavelength lambda of a matter wave. It's the second. Now come here. Dimensional analysis allows us to check the homogeneity of equations, derive formulas, and determine units. Just like algebra, only quantities have the same dimensions can be added. Same dimension like this, x, same, they can be added. If x plus y, we can't add them. It will remain the same. So here the summary of this statement is this: only L be added, T, and they are otherwise they can't be added like algebra. Hope you got the point.